Hi, welcome to Hutsons-Hacks. Today we're going to be looking at Python feature encoding. So, feature encoding the Pandas way. So let's get started. What I'm going to do is launch a Jupyter Notebook. If you don't have Anaconda installed, it's a good way to actually program and install. You can download Anaconda from the Anaconda website and install the application. It comes with Jupyter Notebook. Again, in terms of getting started, you can just download from there with relevant installation instructions. Okay, back to Jupyter Notebook then. So what we're going to do today is we're going to program a Python file. So we're going to essentially look at how we can use machine learning feature engineering. So I'm going to call it standard model feature encoding. And that'll create a Jupyter Notebook for us with that data. So we're going to need a couple of libraries, imports, Pandas as PD, imports, NumPy as MP. Okay, and run that, just bring those commands in. So what I'm going to do next is I'm going to bring in a data frame. So my data frame is from the Pandas library, and it's going to read underscore CSV, and it's going to bring it in from the website. My website is always stored there, so you can download it for future reference. We're going to examine the head of that data frame. Okay, so this is hospital data used as stranded patients. If you've seen my API plumber video in R, it's using the same data set there. So essentially what we're going to do is we're going to use this frailty index, and we're going to create different features based off this frailty index, because everything else has already been encoded the way I need it. And age is a continuous variable, so that's okay for my model. But if I'm preparing it for a machine learning model, we can't have categorical information. That needs to be encoded in a way. So the next step to do, there'll be some NAs in this data set. So I'm going to use df.dropNA, which is a pandas method for dropping NAs. So that'll reduce the dimensions of the data set down. So if I got rid of the head here, I'd be able to see I've got 768 rows, and when it's been dropped, I've got 699. I'm going to specify the data types, D types. This is an attribute. So you can see the stranded label is an object, so it means it's categorical. And I've got two more objects, so that needs converting to date and time, but we're not actually going to use the admit date in this instance. A frailty index is going to be the thing that we're working with. So to select only the categorical variables, I'm going to do it this way. So I'm going to create another data frame called catdf, categorical df, df.select as a method, d types, include, and then there's a list. I'm going to select the type, so object, and we're going to create this as a copy, so a new data frame. And if I examine that catdf in the next cell, you can see I've got all my categorical variables now. So it's selected the object, so stranded label, admin date, and frailty index. And you can see that those that data has been pulled back as a separate data frame. So there's a couple of ways that we can approach feature encoding. First of all, we're going to use the label encoding method. So to get a label encoding, first of all, I'm going to drop some fields in this data frame. So the method to do that is the .drop method. So essentially create a new variable, and my catdf I'm going to drop, and as a list, we're going to pass in the stranded.label, because I don't want that, and add mits. dates. And we need to specify here as another method the axes. So because it's a column, you need to set it to 1. If it was a row, you'd set it to 0, but we're dropping columns, not rows. So if I run that code there, and then I print out catdf again, you'll just see that I've got one column left, which is my frailty index. Now we're going to create the encoding for that. So we're going to say catdf, and we're going to say we're going to actually convert. We're going to act like this is not already. So to convert it to the type of an object, we're going to do that next. We're going to assume that it's not that type of object. Frailty index, and we're going to catdf frailty index, and we're going to say as type, I'm going to set it to the category type. So that's just type conversion right there. And then catdf.dtypes, an attribute, it will show that it's now the data type of an object. So the next thing to do is actually create the category encoding. Create the category encoding. So we need a catdf again, and I'm going to create a new column this time. I'm going to call it the frail cat code. I'm going to set it to my original. So to extend this new, because it won't find it in the data frame, it'll create a new column. Catdf, and we're going to say frailty index .cat.codes, and then that'll create a category encoding. So if I do that now, I'll see that I've got two columns. Original frailty index column, which is the textual description, and then it's created this frail category encoding. So obviously Python starts at 0 indexing. So activity limitation, so the first item it sees will be 0, and then the number of items it will start to rank from there. The trouble is with this in a machine learning model, these categorical variables have got no real importance over another. There's no real sequence or rank that can be derived from them. So this will cause confusion when you put it into a predictive model. So the next thing to do, and something that a lot of programs do, is something called one-hot encoding, otherwise known as dummy variable encoding. So that's the next type of encoding. So this is essentially label encoding. This one's my one-hot encoding. So here, I'm going to go back a step, and I'm going to use my categorical data frame, and I'm going to use the pandas get dummies argument. I'm going to use a catdf, and I'm going to specify my columns. You have to pass it as a list. So it allows you to set multiple columns here. Frailty index. If I specify that, you can see now actually really quickly that my previous text descriptions have been transformed into a binary encoding, so a dummy encoding and one-hot encoding. So if it belongs to that class, it's going to be 1. If not, it's going to be 0. And then the next one, you can see by linking it to the actual textual description that it's assigned the relevant categories. There's something in regression models called the dummy variable trap. So normally you'd get rid of one of these, you'd have one of these as a control variable. So the one here, no index, is probably the one that you could get rid of. I'm not going to do that in this instance, but essentially it's as simple as just dropping the actual columns that you need to drop, because these are now columns as opposed to rows. So now the last thing to do would be, if you wanted to combine this with your actual data, you'd do a concatenation. So I'm going to call this combined. So I'm going to use my original data frame. I'm going to use the pd concat, so concatenate method. Pass it through as a list again, df, and I'm going to specify, oh, did I set that to dummies? Just let me set this as a variable to dummies. call that my dummy variables. I'm going to print that out again. Okay, there's my dummy variables. Here I'm going to specify df and dummies to bind together. I'm going to bind it on the column axis as we've done before. You can see now if I print this out, combined, you'd do print if you were in Visual Studio Code. So you can see now I've got this stranded label, I've got all my data. What I'd probably do now, because I've got these encodings, I've got duplicate columns here. I'm going to get rid of the admit date, the frailty index, and the frail cat code, because actually if you use the frailty index, this is a representation of frailty index. And there's essentially, if you'd put that into a model, you'd get correlation between those columns. So what I need to do now is drop that column, or drop that series of columns. So the next thing to do would be to set up my final data frame. So I'm going to use the combined that I've done already. I'm going to drop my admit date, my frailty index, and my frail cat code. Let's see to amend that. And I'm going to specify it on the column index. And if I view that final data frame, I can see that these have now been dropped. The next thing to do, okay, would be to, if I want to create my own custom encodings, so I do it like this. So I'm going to look again at my cat df, the one that I used before. So I'm going back a data frame, and I'm going to set my frailty index again as my reference column. I'm going to set the value counts method. Okay, you can see actually in my frailty index I've got this label here appears 371 times. Full patient history, activity and limitation, and mobility problems. If I wanted to create a new column based off one of these values or multiple values, we'll just do it on one. I can use this. So I'm going to create on the category data frame, I'm going to create a new column. I'm going to call this mobility issues. And MP where. So I'm going to search in NumPy where my categorical data frame frailty index string contains, so within the row, so within the string, I'm just going to set it to mobility problems. And if that's the case, let's give it an encoding of 1, otherwise 0. So if I run this now and then print out catdf, you'll see that I've created my own encoding. So mobility problems and the frail category encoding there. Okay, so that completes the more basic methods. In the next tutorial, I'll get onto more advanced encoding methods, and there we'll use scikit-learn, and we're going to use some other statistical packages to do different types of encoding. So watch this space and follow the next video when it becomes available. I hope you've enjoyed the videos, and subscribe, keep following, and I look forward to seeing you in the next tutorial. All right, guys, have a good day.